2024 has seen a lot of astronomy and astrophysics news announced, and while I've tried to cover as much as I can on this channel, I could never keep up with the pace of work of my colleagues because over 31,000 astronomy research papers have been published in 2024 alone. Some of those made a bigger impact than others though, so as is becoming tradition on my channel, I figured since we're nearing the end of the year, let's count down my top 5 biggest space news stories of 2024. Before you watch the rest of this video though, why don't you put your guesses for what my number 1 spot will be down in the comments. In the meantime, let's start with number 5, Neptune's true colour of blue. Because it turns out Neptune is a different colour to what we all think it is. The only probe to have visited Neptune is Voyager 2 back in the 1980s when it flew past all 4 of the gas giant planets on its trip through the solar system. And so the best image we have of Neptune is from that flyby. It's a very iconic image, and yet it is not what's known as a true colour image. The blue colour we've all got used to is not what you'd actually see with your eyes. It is a false colour image. The levels have been played with to enhance the different features that were in Neptune's atmosphere. And that was very clearly communicated by NASA in the press conference back in 1989, but we've just apparently all collectively forgotten. Instead though, a new paper by Irwin and collaborators released earlier this year reprocessed the raw image data taken by Voyager for both Uranus and Neptune to produce a true colour image of what you'd actually see with your eye. And now they practically look like twins. Gone is Neptune's deep blue colour, and in its place is a hazy pale cerulean. Now I covered how they did this, how they reprocessed those images, taking the black and white images from the telescope, taken through filters that only let through certain colours of light, in a video at the time which I'll link down below. But the really wonderful thing about this big story about how Neptune's colour had changed was actually a footnote to the main science that Irwin and collaborators were trying to do. What they really wanted to do was figure out why Uranus's colour seems to change with time and change with the seasons as it orbits the sun. And to do that, they needed the true colour of Uranus from the Voyager images to calibrate the observations they had from ground-based observations taken over decades. And I just love the idea that while they were reprocessing Voyager's Uranus images, one of them had the thought like, hey, should we do Neptune as well? Not realising what an absolute can of worms they would open in the process. Next up on my list is the observation of black hole plunging regions for the first time. So most stuff near a black hole will actually end up in orbit around it, kind of like the planets in the solar system orbiting the sun and not getting pulled in towards the much heavier sun. And that stuff will form a disk around the black hole. It'll be this swirling superheated matter that's moving so fast that it glows in X-ray and UV lights that we can see it and know the black hole is there. And there is an inner edge to that disk of material around the black hole. The last place that you can get a stable circular orbit. It's what's known as the innermost stable circular orbit, or ISCO. Inside that is what's known as the plunging regions, where material can no longer have a stable orbit around the black hole and will just fall towards it, eventually becoming part of the black hole when it crosses the event horizon. Now in theory, that material that's in these plunging regions inside the innermost stable circular orbit, but not having yet crossed the event horizon, that point of no return where we don't get any information from the black hole, that material should also be giving off some form of light, X-ray light, that we should be able to isolate from the X-ray light that's coming from the accretion disk as a whole and prove that these plunging regions exist. Which is exactly what Mummery and collaborators managed to do earlier this year for MAXI J1820+070, a black hole about 8 times the mass of the sun. It's about 10,000 light years away in our own galaxy, the Milky Way. And they got what's known as a spectrum, where you get a trace of how much light at each wavelength this black hole is giving off, specifically in X-ray light. And they showed that you couldn't account for all the X-ray light detected without a plunging region being part of your model. They had observed the material falling into the black hole for the first time. And I love this study because it also gave us a new way of measuring black hole spin, which I care about in my research because it traces the history of the black hole. And I went into all of that in the video I made about this result earlier in the year, where I had a chat with the first author of this paper, Andy Mummery, since he was just next door here in Oxford after all. Next on my list, we couldn't have a wrap up of space news in 2024 without a result from JWST, the James Webb Space Telescope. So at number 3, I have JWST breaking the record for the most distant galaxy once again with the discovery of JADES-GS-Z14-0 that was published by Carniani and collaborators on the JADES team earlier this year at a whopping redshift factor of 14.32, meaning that the light from that galaxy has been traveling through the universe to us here on Earth for a whopping 13.4 billion years, meaning that we're seeing that galaxy as it was when the universe was just 300 million years old. I was so in awe of those numbers that I had to put them into context for you all and make one of my Record Breakers series videos on all the galaxies that have held the title of most distant galaxy known over the years. Just to give you some context of how us astrophysicists are feeling when it comes to these new discoveries. And the reason why JADES-GS-Z14-0 was such a big deal was that its redshift or distance was confirmed using a spectrum, where you take the light and split it into its rainbow, so you get a trace of how much light at each wavelength or colour you are seeing. And that way you can pinpoint much more accurately that redshift factor, how much the light has been stretched out by because it's travelled through expanding space. I covered how this is done in my Night Sky News episode for June 2024 when this was first announced, if you want to check that out. But know that it is a much more accurate way of doing this, at getting at the redshift, than just using the images from JWST alone, which is what's been done for a lot of the initial claims of candidate galaxies at those redshifts, which then mostly end up getting revised down to lower redshifts when we get spectra for them and end up being a little bit of a letdown, but not JADES-GS-Z14-0. It came out spectra ablazing. Now, next on my list is of a similar vein, but instead of the most distant galaxy ever found, at number 2, I've got the fastest growing supermassive black hole ever found. The discovery was published back in February of 2024 by Wolf and collaborators. They claim to have found a black hole 70 million times heavier than the Sun that was growing, taking in matter at a rate of 370 suns worth per year. Or to put it another way, a sun's worth of matter every single day. I just want to get across how absolutely insane that number is. Like, I work with growing supermassive black holes all the time, and the numbers that we tend to work with for like growth rates range from like 0.1 to maybe just over 1 like sun's worth of material per year, not per day like this one that's been found by Wolf and collaborators. The numbers here are absolutely insane. To be growing at such a huge rate, the disk of material that's spiraling around the black hole and eventually, grow the black hole has to be absolutely huge. A back of the envelope calculation puts it at about 7 light years across. For context, the famous first ever image of a black hole of Messier 87's accretion disk in radio light is 0.013 light years across. This black hole's accretion disk is 500 times bigger than that. It is 15,000 times the distance between the Sun and Neptune. Like, these are the kind of numbers that make even us astrophysicists just stop in our tracks, which is why it makes number 2 on my list. But before I get to what my number 1 is, I want to highlight a few honourable mentions and near misses. So starting with honourable mentions, first up, 2 Earth-like planets found by the TESS mission in the habitable zone around their star, plus JWST's discovery of the oldest exoplanet ever discovered, and of course the launch of the Europa Clipper mission to the Jupiter system to investigate whether Jupiter's moon Europa is habitable. Let's hope some of Europa Clipper results make it into my video for the top 5 space news stories of 2030 or 2031 by the time that it makes it to Europa. But finally, I want to highlight a near-miss news story of T Corona Borealis, the star that was predicted to go nova and become a new star in our skies somewhere between July and September this year. But sadly, nothing has happened yet anyway. These things are notoriously difficult to predict, but it is thought to be imminent, so fingers crossed it happens at some point in 2025. But now, we have reached the #1 astronomy news story of 2024 in my list. Drumroll, please. Of course, it's the crisis in cosmology, aka the Hubble tension, which we all hoped that JWST would help to solve, but this year it seems to have made things just ever more confusing. If you've been subscribed to this channel for a while now, you will know all about the crisis in cosmology, which I have been covering for years. But if you haven't or you can't remember, a quick recap. We have 2 main methods for calculating the expansion rate of the universe, which in turn gives us the age of the universe. Those 2 main ways are first with observations of relatively nearby galaxies, and the other with our best fit model of the entire universe. And slowly but surely, over time, the values we get with each method have been drifting apart as we got better and better data from better telescopes, to the point where it's a statistically significant problem that they don't agree. Hence, crisis or Hubble tension. So either there's something wrong with our observations of the universe, or there's something wrong with our best model of the universe. And it was always the hope that JWST would be able to help in both scenarios. Now, figuring out what's wrong with our best model of the universe is more of a long game thing, but in the short term, it was thought that JWST would be able to relatively easily tell us whether there was anything wrong with our observations of nearby galaxies. So in January 2024, we got 3 papers from one research team led by Adam Rees, saying that JWST ruled out the most likely explanation for the crisis in cosmology, and that there didn't seem to be anything wrong with our observations of nearby galaxies, and it was more likely that there was something wrong with our best model of the universe. But then, in spring of this year, we started to hear from the other research team working on this with JWST, which is led by Wendy Friedman. Friedman was on like a seminar tour of Europe presenting their latest results, which seemed to show that JWST had solved the crisis in cosmology and that the problem had completely gone away. But then when they came to write up that work, they found a small hitch in the analysis that needed correcting for, so that by the time that the research papers from this team were published, the problem hadn't gone away completely, and instead they found that they got 3 different values for the rate of expansion of the universe, depending on what type of star they used to calculate the distance to nearby galaxies. One of which then gives a value for the expansion rate of the universe that agrees with the value that we get from our best model of the universe, and another one that completely disagrees with it. So Friedman and collaborators ended up arguing the exact opposite of what Rees and collaborators were arguing. They said no, it wasn't likely that it was going to be new physics in our best model of the universe. Instead, they were like, the reason for the Hubble tension is probably because there's something wrong with our observations of nearby galaxies. So what you got is 2 research teams who are using effectively the same data from JWST, but concluding 2 different things. Yay, science! Thankfully, the Rubin Observatory in Chile, which is coming online next year in 2025, should help us find more of these supernova in distant galaxies, the kind of stars that we can use to calculate the distances to them, which should help reduce the uncertainty on our value of the rate of expansion that we calculate. I also made a video about Rubin this year if you want to know more about it and why the astronomy community is very excited about it, not least because it might finally help us solve the crisis in cosmology. So there you have it. There are my top 5 astronomy and astrophysics research news stories of 2024. And I don't know about you, but I cannot wait to see what 2025 will bring. And if you still haven't had enough of space or science news stories, then why don't you check out Nautilus magazine, who are the sponsor of this week's video. Nautilus is my favourite science magazine. It balances rigorous scientific reporting with pure style, whether that's writing style or the beautiful artwork that accompanies the stories. I love that Nautilus explores like the big ideas in science, you know, the kind that are still going to be debated like long into the future. So for example, like the astrophysics coverage explores the science and philosophy of the universe with articles on dark matter, fine-tuning and astrobiology. Like Caleb Scharf, senior scientist for astrobiology at the NASA Ames Research Center, who recently won the Carl Sagan Medal for Public Science Communication. So I just know that I can trust Nautilus to have really nuanced and interesting science pieces that like never fail to blow my mind. You can join as a digital only member or in print to receive 6 beautifully illustrated award-winning collectible editions per year, which look wonderful on the coffee table, trust me. So join me in reading Nautilus in 2025 by heading to joinnautilus.com/Dr. Becky, or you can click on that link in the video description down below and you'll get 15% off your membership to Nautilus. A perfect New Year's treat for any science enthusiast. So thanks again to Nautilus for sponsoring this video. And with that, I'll see you all in 2025. I don't think you can see her, can you? There she is. Say hi, Pip. Say hi. Can you see yourself? Yeah. Drum roll, please. Oh, that really terrified the cat. I'm so sorry. I also shouldn't do that because we should probably put the drum roll in audio, so there's no point me making a drum roll noise, is there? One of which, oh, she's just gonna curl up right next to the tripod legs again. Why? Just see it just slightly wobbling. Let me just, could you not? Like, she's fully, like, wrapped her entire body around one of the tripod legs. What are you munching? Oh, okay.